Good morning, students. Yesterday we have started our electricity and we have studied charge. We have done that charge is an internal property of matter which give rise to electricity. So let us proceed to charges. Now you see charge and then come for charged body. Which body is said to be charged body? Charged body, when we rub glass rod with silk, charge from one body flows to another body. Or when we rub ebonite rod with wool, again charge from one body flows to another body. But before rubbing, what happens? The total number of electrons is equal to total number of protons in the body. That means both the negative and positive charge are equal. So, when both the negative and positive charge are equal in any body, then that body is known as electrically neutral body, where number of electrons is equal to number of protons. For example, I have taken this marker. This is electrically neutral body. When I will rub with any dry hair or silk or wool, then charge will flow from one body to another body. So let us see that how we will differentiate it. When number of proton is greater than number of electron, then that type of charged body is known as positively charged body. So here you will see that when any object lose electron, then number of proton will be greater than number of electron, and that type of charged body is known as positively charged body. Another case, when number of electron is greater than number of proton, that means when any body gains electron, then what happens? Number of electron increases comparison to number of proton, and that type of charged body is known as negatively charged body. So this charged body, either the number of proton is greater or number of electron is greater. Number of electron is greater, negatively charged body. Number of proton is greater, positively charged body. And when both are equal, then that body is known as electrically neutral body. So I hope you have understood about charge. So let us see what are the different properties of electric charge. First property, force of interaction between two charges. What is the force of interaction between the two charges? Just you see it. Like charge repel each other. Like means here we are saying same charge. Same charge repel each other means if you will bring positive and positive, when they approach each other, they will feel the force of repulsion. They will just go away, apart from each other. So this is force of repulsion. Repulsion. When negative charge and another negative charge approaches each other, they will also feel a force of repulsion. Both will go apart from each other. So that is force of repulsion. Next to come, unlike charge attract each other. Unlike charge means not same charge. So here when positive and negative approaches each other, they will attract each other. This is force of attraction. Force of attraction. the another property of charge. Now you see here, second property we are studying quantization of charge. That means charge is quantized. We have studied that charged body becomes when either there is excess of charge or there is deficiency of charge. So, excess of charge or deficiency of charge. So, charge on a body is integral multiple of the charge on electron. So, as you see here, if we are denoting electron with E and we know that the charge on an electron is 1.6 into 10 to the power minus 19 coulomb. For another body, the charge may have either E or 2E or 3E. It does not have 2.5E or 8.2E. This is not possible because either there is excess of charge or there is deficiency of charge, but we are not dividing the charge. It is not, we are not breaking the charge. So it is a quantized, that is integral multiple of charge on an electron. Another property you come, conservation of charge. Conservation of charge, we know that charge can neither be created nor be destroyed, but only it can transforms from one form to another form. So as it transforms from one form to another form, means either there is charge in excess or there is charge in deficient. So as the charge in excess or there is deficient, that means when we consider the net charge of any isolated system, it always remains constant. For isolated system, it always remains constant. So that is conservation of charge. And last property is charge is scalar quantity. It has magnitude only. It has no specific direction. We can add proton and neutron, that is, it is added algebraically, so we say that charge is an scalar quantity. So this all are property of charge. You revise it. Okay.